Hello. Volts, DC. How you doing, Jason Joplin? Yo, yo, yo. So, Jace, while I got you on first, so I tried your setup, far as regards to coming off the PMH into the AC capacitor and going into the DC after a bridge rectifier. And you can see I have, well, you can't see, but up here, I got the AC capacitor right there, the DC capacitor there. I'll show all this stuff off in a few minutes. Going on, William in the house. Hello, hello, Mr. U. So, one thing I noticed that, let's wait one more minute and a couple more people jump on. And can you see this voltage here? Can you see that says 28 volts? 28.4. Can you see it over there? Somebody give me a thumbs up. Can you see that? No, okay. But you see that, right? What's up, Adam in the house? You see that? So I guess I'll just have to, what I'm going to do is, that's 28 volts in that capacitor right now that's stored up in that DC capacitor. So got Jason on here, and Jason had a nice little diagram of the setup there. And this is what we're mimicking right now, Jason's layout. This is a reed switch right there. And the reed switch pretty much is, all right, let me pick up this phone here. I'm going to take you guys through the whole thing. You're going to like this. You're going to like it. And what we're going to do is we're going to charge that capacitor and we're going to dump it by using the reed switch. So every time the magnet goes by the reed switch, it dumps the capacitor. So I got, what, I don't know, 4.5 watt group of LEDs up there that is going to dump every time that the wheel changes its polarity. Cool as shit. All righty. So let me take you through the layout here. All right. So capacitor. Here we go. So we're coming out of the PMH and we're going into this multiplier. Now I'm coming out of the multiplier, AC on both sides. Now, Jason, that is set up also to do what you had in your circuitry there, but I couldn't get enough voltage that I wanted. You could tell by how the lights stay on and powerful, and I needed to step up the voltage before it went in here. But then when I did that, that eliminated the AC capacitor. So the AC capacitor is not on this demonstration, but it does work. But I can gain more volts on this right here. So if I don't use the multiplier and go straight into that, which works, this will maintain about 19 volts. All right, 18 volts, maybe 17. So we're doubling the volts by using a multiplier, but you come out of the multiplier DC. So we're going into this DC capacitor here. We're coming, so we're coming out of the multiplier with both sides, okay? So here's the DC capacitor. It is 6,000 microfarads. Okay, so now I'm coming out of that and I'm going, let me just check these wires for you guys so you know where they're coming out. So the PMH, I noticed when I use one, I get half the voltage. How I'm even getting this voltage right now is because I'm coming out of one PMH, going into the other PMH. Coming out of that PMH and going into the voltage multiplier, one side of it. The voltage multiplier is a AC to DC circuit. So basically, it doesn't matter which one you put on there. You're just gonna make sure you're coming in and you're going and you're coming in two ends. So that is coming out of the coil here to over there, out of there, back and covering that side of the multiplier. And then you come out of the DC of the multiplier. I just stuck a capacitor there, and I'm feeding off the capacitor, and that's coming out and goes to the voltmeter, and then it also goes to the main capacitor. Now the main capacitor, I'm over here and I'm feeding this LED 4.5 watts it takes to run that. Let me see, what's the other half? Missing a wire. Here it is. So pretty cool setup. And man, like Jason suggested it, and I was like, this is like key. So I got 26 volts saved up in here. Let's go ahead and you see that? I just moved the, watch, I'll move the reed switch over. Watch the light light up. So we're burning down the juice in here. What's going on, Mike? Hello. So now we got 16 volts in it, right? Now I'm going to bring it closer. Let's burn up some of the volts. All right, so now it's dropped down to 10 volts. Let's do it again. All right, lights on. Let's just bleed it down. So right now we're bleeding it down. We got 8 volts. Light's still on. This is good. You can look at this. This is 6,000 microfarads of capacitance. All right, lights are still on, and we're still at 7.7 volts and dropping slow. Like, not fast at all, guys. This is cool stuff. Still got 7.5 volts. Now the lights are real dim because this is a 12 volt. Yeah, Jason, this is way cool, man. So let's go ahead now and watch this. So I moved the reed switch out of the way. Now I'm going to turn the wheel, and we're going to get the volts up, and we're going to get it up a little bit above 30. So look at the speed of the wheel. You can see how much energy is going to be in there to turn it that fast. 34 volts. Now let's go ahead and put the reed switch in here. Let's start dumping that capacitor, that energy. Lights on bright right now. Power dropped down to a steady 9. And now you can see we got flashing of the lights. So the lights, the reed switch is dumping that capacitor in that light right now. So we're maintaining 8 to 9 volts, drop a little bit, the speed's dropping down. So if we kept the speed up, let me give it just a little bit more. I can bring the speed up a little bit. You can see the volts goes up, the bright light. Yeah. No, I'm using mine. Why? When I get done videoing, I'll come in and you can check my thing, okay? All right. Love you. So you can see the volts stays down low, but if I take away the reed switch, the volts start building up again. So there you can see 6,000 capacitance, what its capabilities are, as well as what this is capable of. We're not even, this is just spun. The connections are just sitting here to nothing. And the whole key is to dump a capacitor, this capacitor, or something like this, into this. And what I want to do is, the first thing I want to do is only dump the two magnets, or the one magnet, that group, at like that here. So that back EMF of that is going into this coil array, which is going to blow the heck out of this stuff. The volts you're seeing now is going to increase because my magnetic strength is going to increase. So I'm excited about that. We're on a good trail right here. Good suggestions there, Adam. Good suggestions. So you can see here, look, we got 14 volts. Let's go ahead and build this up again. Let's get it up. And it holds the volts. So turn the wheel, we'll get it up to 30 again. $33 volts. We'll go ahead and get the reed switch dumping the capacitor. You can see the reed switch opening and closing. So we got 7.8, wheels turning slow, and the light's still barely on, so we're still burning some power. And the capacitance, this to me would be the combination of what the induction is of these guys, the 4.5 watts of induction. And so that induction takes that voltage just to get it saturated. So we're kind of, I think I'm right about the saturation about this. Leave your comments, guys. Help me out here. So we still have 6 volts here, which if I had little LEDs, they still be, yeah, and I agree. So dumping on a quarter turn eliminates, say this, say I get a driver PMH, okay? And the driver PMH is only banging, not, it'd be the poles stay the same on the PMH, and it'd only be banging when the opposing pole comes to it. So it would skip one, you know what I mean? Just like you said, Jason, it would skip. And that would be the driver that moves the wheel, but it's going to take energy. But I guess what we're going to have to do is first start it off with some low voltage, little DC, little batteries, and to get the wheel turning, and then somehow be able to be charging another battery as well as using the battery. I don't know. This is just gonna evolve, but I don't want any batteries really But the thing of conservation here is really important to me, because think about how much energy I'm wasting if I fire up all these coils at one time. It's ridiculous. It's ridiculous. I should have in front of every coil a sensor that activates these pair into these, so I get the most extreme intensity at this place, with all this being part of the function, but I don't want them activated. I want individual quadrants activated. I'm calling this a quadrant. That's another quadrant, or another corridor, you can call it if you want. Then I'll have a pickup coil. So with the driver coil, you're going to use energy, and then we can go against what we're bringing in, and we can see what we can accomplish on trying to get power in and see what power out. All right, guys, you leave your comments. Hopefully you enjoyed it. Do one more little test run here. It's pretty cool stuff. So we're building voltage. I got the reed switch off. So let me go ahead, lights back on. Why? I don't know. That's not good. That means the reed switch is stuck. Yeah. Here it is. I just loosened it up. I just did, Adam. I flicked it. All right, there you go. So then we're going to increase the voltage. So I got to get it up to a certain speed. And that certain speed, rate of change, is causing the volts to go up. It's that rate of change that I notice is what it's all about there, the rate of change. So increasing the strength on the magnets with that rate of change is going to really amplify everything here. It's going to really amplify it. So let's go ahead and put the reed switch in front. You'll see the lights go on. You see the reed switch. It's stuck again. Here it is. Hear it? All right. That's crazy. I wanted to show you something. You see how it drops to 8, 9 volts? Now it's building up, right? So if I increase the speed and don't let the speed slow down, watch what happens to the volts. So let's get the volts up to 30 again. All right, so we're up to 32. Some good speed going. So now we're gonna, all right, it's working. You hear it? Volts are at 9. Now let's get the volts up again. No. Let the volts get up. All right. No, can't keep the volts up. So the volts drop down to 9. That is switching right there. That is switching. Now you can hear that. Well, that's what I got set up, guys. Reed switch to the coil. So that's turning this, well, not turning it, I'm turning the damn thing, but. So if you have a good suggestion, leave a comment on something about coming out of the reed switch into what? I'm coming out of the reed switch into the, well, what's coming out of here? So I'm coming into my load and I'm going out into the reed switch from both ends of the capacitor. An amplified frequency. I got to think about that. How do you amplify the frequency? On the generator coil. So this right now is the generator coil. Well, why? The reed switch is going to get stuck, you're saying? All right, guys. Leave your comments. I'm paying attention. It's producing on its own with me turning it.